Good morning, students. Your teacher here, Mr. Shirasinski, with an episode of Geometry. This is lesson 1-3, the distance formula. And this is a pretty important lesson in geometry. Okay, the distance formula is something that you will definitely be tested on in the EOC and something you'll be expected to know. And so let's just go ahead and jump right into it. And we use this to find the distance between 2 points. Especially when they're at a diagonal, right? If it was a flat point, we could say, okay, that's 5. But when you have a line at a diagonal, it gets a little trickier, okay? So the distance formula is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, and so in our first example, it says find the distance between the 2 points on the graph. So we have the points, let's start at the origin. That's negative 5, 3. And this is negative 2, negative 3. Okay. So I'm going to make negative 5, 3. This will be my x1, y1. And negative 2, negative 3 will be my x2, y2. So let's go ahead and set up the formula. Distance equals square root of negative 2 minus negative 5 squared plus negative 3 minus 3 squared. All right, so let's start to simplify. Negative 2 plus positive 5 is going to be 3 squared, which is 9. And negative 3 minus 3 is negative 6. And negative 6 squared is 36. If we add those together, we get the square root of 45. And the square root of 45 is approximately 6.7. 6.7 what? I just like to say 6.7 units. So that's how long that line is. All right, number 2. Find AB given that A is negative 4, 1 and B is 3, negative 1. So we're given our 2 points. Best practice, go ahead and label them. That's x1, y1. That's x2, y2. And set up your formula. Distance equals the square root of 3 minus negative 4 squared plus negative 1 minus 1 squared. All right, so minusing a negative is the same as adding a positive. So 3 plus 4 is 7. And 7 squared is 49. Negative 1 minus 1 is negative 2. And negative 2 squared, anytime you square a negative, it becomes a positive. It's 4. If we add those two together, we get D equals the square root of 53. And the square root of 53, if you put that in your calculator, is approximately 7.3. Number 3, find EF given that E is negative 7, negative 2, and F is 11, 3. Label your points, x1, y1, x2, y2. Set up your formula. D equals square root of 11 minus negative 7 squared plus 3 minus negative 2 squared. 11 minus negative 7 is the same as plus positive 7. That's 18 squared. And 18 squared is 324. 3 minus negative 2 is the same as 3 plus 2, and 5 squared is 25. If you add those two together, you get the square root of 349. And if you put that in your calculator, the square root of 349 is approximately 18.7. Okay. Moving on. Now we're to our next big part of this lesson, the midpoint formula. And just like the distance formula, this one's also important. So the midpoint formula is midpoint equals, and to find the midpoint from 2 points, all you do is add x1 and x2 and divide by 2. And you do the same thing for the y's. y1 plus y2 divided by 2. This should make sense because you're basically just finding the average of the two, and that gives you the middle. Okay, it gives you the mean of the 2 points, which technically is the middle. All right, so let's work our first example here, number 4. Find the midpoint of GH, given that G is 7, -5, and H is 9, -1. Just like in the distance formula, it's always good to label your points. Just takes any of the guesswork out of it. You know exactly where to put everything. So midpoint equals x1 plus x2, that's going to be 7 plus 9. Divided by 2, and y1 plus y2, that's -5 plus -1, divided by 2. All right, 7 plus 9 is 16. 16 divided by 2 is 8. And -5 plus -1 is -6. -6 divided by 2 is -3. So the midpoint is at 8, -3. Number 5, find the midpoint of AB, given that A is -7, 4, and B is 3, -4. So I'm just label them as I go. Midpoint equals x1, -7 plus 3 divided by 2, and y1 plus y2, 4 plus -4 divided by 2. -7 plus 3 is -4. -4 divided by 2 is -2. And 4 plus -4 is 0, and 0 divided by 2 is 0. So the midpoint is at -2, 0. Keep going. Finding a missing endpoint. All right, so we got to work a little differently here. Find the coordinates of A if M is the midpoint of AB and B has coordinates of 3, -5. All right, so we're finding the missing endpoint here, and this is using the same formula. This is the midpoint formula, but we're just going to have to do a little solving, a little algebra. Okay, so we'll set it up the same. If coordinates of A, if M is the midpoint of AB and B has coordinates of 3, -5. So we're going to make 3, -5 our x1, let's see here, x1, y1. And this is going to be my midpoint. This is going to be my xy. So we have, for the x value, -1 equals 3 plus x divided by 2. And then for the y value, we have 2 equals -5 plus y divided by 2. Okay, so these are just equations that we need to solve. And for each of them, the first thing we need to do is we need to clear this number in the denominator. And we're going to do that by multiplying each side by 2. Okay. And if we multiply each side by 2, I get -2 equals 3 plus x, and I get 4 equals -5 plus y. And then now, and these are both just two-step equations, okay? So we multiplied, and now we need to add or subtract. So we're going to subtract 3 here, and x equals -5. And we're going to add 5 here. Y equals 9. So the missing endpoint is -5, comma 9. All right, next example. And this was point A. Find the coordinates of J, so we're looking for J, if K, -5, 10 is the midpoint of JL, and L has coordinates of -8, 6. So that's my x1, y1, and this is my x and y for my midpoint. So -5, this is the x, equals -8 plus x divided by 2, and 10 equals 6 plus y divided by 2. Okay, so same process. Okay, it's a two-step equation. Multiply by 2 to clear the denominator. And by clear, I mean get rid of it. Okay, so those cancel out. 2 times -5 is -10. 2 times 10 is 20. And then subtract 6 from both sides. Y equals 14. Add 8. X equals -2. So the endpoint of J is -2 and 14. Number 8, find the coordinates of R if Q is the midpoint. So that's my X and Y. And P has coordinates, so we're looking for R. P has coordinates of 5, 6. So we have -1 equals 5 plus x divided by 2, and 3 equals 6 plus y divided by 2. Okay? Multiply each side by 2 to get rid of the denominator. Okay, so 5 plus x equals -2. 6 equals 6 plus y. Subtract 6. Y equals 0. Subtract 5. X equals -7. So the missing endpoint, -7, comma 0. All right, and a couple more using algebra. If P is the midpoint of xy, and xp equals 8x minus 2, and py equals 12x minus 30, find the value of x. So this is using what we know about midpoints, and I think it's helpful in these examples to draw a diagram. Okay, so we have xpy, okay, and P is the midpoint, which means these two are congruent, and xp equals 8x minus 2, and py equals 12x minus 30. All right, so if P is the midpoint and those two segments are congruent, then we can set them equal to each other. 8x minus 2 equals 12x minus 30. And this is similar to what we were doing yesterday when we were doing the segment addition postulate, okay? So we're going to solve for x, get x on one side of the equation first. It's going to be -4x minus 2 equals -30. Add 2 to both sides. -4x equals -28. Divide by -4. X equals 7. Number 10, if G is the midpoint of FH, so here's FH, and we have G in the middle, which means GH and FG are congruent. FG equals 14x plus 25, okay, and GH equals 73 minus 2x. Find FH. All right, so we need to find x first, and then we need to substitute x into both of the expressions and add them together to get the length of FH. So here we go. 14x plus 25. First step is going to be the same as the last one. Okay, we got to find x. So we're going to add 2x to both sides. 16x plus 25 equals 73. Subtract 25. 16x equals, 48. And divide by 16. X equals 3. So if x equals 3, then we can substitute it into both of those expressions and add them together to get the length of FH. So we have FG, it's going to be 14 times 3 plus 25. And then GH, it's going to be 73 minus 2 times 3. 14 times 3 is 42. 42 plus 25, let's see, 42 plus 25 is going to be 67. And then 73 minus 6 is going to be 67. And they should be congruent because G is the midpoint. So technically, we only had to find the length of 1 and just double it, just to be clear here. But 67 and 67, 60 and 60 is 120. 7 and 7 is 14. Add them together, you get 134. So FH equals 134. All right, number 11. Use the diagram to the left. If line N bisects QR, find QP. So if line N bisects, okay, then that means this segment and this segment are congruent. And that means we can set QP and equal to PR and solve for X. Once we find X, we can substitute it into the expression here to find QP. So here we go. Start off by setting them equal to each other. Okay. Get X on one side, subtract 5X from both sides. Negative 2X plus 5 equals negative 19. Subtract 5 from both sides as we start to isolate the variable. And then divide by negative 2. X equals positive 12. So if X equals 12, then QP is equal to 3 times 12 plus 5. And 3 times 12, that's 36. 36 plus 5 is 41. So QP equals 41. I'm your teacher, and this is the way.